So today we are going to solve a question called twoSum. This is one of the classic problem that the pattern that we'll discuss to solve this problem will be used in many other type of questions. So yeah, I think this is a great question to solve, and let's get to it. So this is a easy problem, but once again, the pattern that we'll be using is going to be quite important. So I think it is important questions to go over. So in this problem, we have an array of integers and a target as an input. So we need to find the return indices of the two numbers such that they add up to a target. And there will be also exactly one solution. So as soon as we find a solution, we just need to return the indices of two pairs. Here is an example array of integers 2, 7, 11, and 15, and target is 9, and we have 2 and 7. The sums up to target. Their indices are 0 and 1. The 2 is in the index 0. The 7 is in the index 1 position. So it is returning 0 and 1. It's very simple. So let's look at it and do the problems together. So we have numbers, array of integers, 3, 5, 1, 4, and -8. And let's say target is 5. And I like to add an index of these numbers. So what are we returning here? What makes a target 5? As clearly we have 1 and 4. The value 1 and value 4. The 1 plus 4 is 5. And what are their indices? It's 2 and 3, and we are returning 2 and 3. So let's just go through a brute force way. Brute force way is just trying every single combinations until we find an answer. So to try in this such a way, we need 2 pointers. This will be a nested loop pointer referencing 0, and we have another pointer 1. So given 2 pointers, we'll be adding and see if this sums up to our target. Add up to our target, and keep sliding. Start with J, and keep checking if those two numbers, 2 pairs, are the answer. Add up to our target. Once J reaches the end of the list, we will have to update the reference, the pointer I, to 1, and repeat this process. And at the end, it will find an answer when I is referencing 2 and J is referencing 3, 1 and 4. So this is a nested loop problem to do this way, and quite simple. We have outer loop with called I using my examples using my example. I use I as the outer loop, and the inner loop will be J. Just to note that the outer loop will be looping from 0 to the entire list, the length of the array. In J, however, we always want to start wherever the I is, and it will loop through the end of the list. And once the number is, it adds up to our target, then we just need to return it, and that will be it. The issue here is that brute force way is easy, but it's not very efficient. That the time complexity is n squared. So how can we improve this, optimize this solution? That's what we're going to look at. Because it's an array of lists, because it's an array, we have to scan, at least visit each number once. But while we are visiting each number, I think we have a lot of information here. We know the target, and we know the current number. So what we can actually compute is, what's the missing number here? In this case, 5 minus 3. The target minus current number 3 is 2. Do we know that if 2 is somewhere in the list? If there is, then we have an answer. So how can we efficiently check the missing number if we have seen this missing number? This is the Hashmap problem. We can Hashmap to store the important property that can help us to solve this problem. So start with 3. Obviously, the Hashmap is empty, so answer will be no. No, we have not seen 2. If that's the case, we need to store the current number 3. 3 as the key. So because we need to be able to look up the number very efficiently. So we want to store the number 3 as the key. And because once we find that answer, we need to return the indices of those pair, we want to store the value, the index as the value. 3, which is the current value, and 3, the index for the 3 is 0, so we want to store that 0 as a value, as you can see from the Hashmap here. So that is stored. Now let's scan the next number. I equal to 1, index is 1, we have value 5. 5 minus 5, which is target minus current number, is 0. Have you seen 0? Answer is no, so we want to update the Hashmap with the current value 5 and index 1. And let's continuously scan the array and check the next number. I is equal to 2, index is 2 now, which is the value is 1. 5 minus 1 is 4. Have you seen 4? Answer is no, so we want to update the Hashmap with this new current value 1 and index 2. Now I is equal to 3. The value is 4. The missing number is 1. 5 minus 4 is 1. Have you seen 1? And answer is yes. In the previous, the index for the value was 1. So we have an answer. Because we are returning the indices, we have to graph the current index, which is the current value I, and the value from the Hashmap, where the key is that missing number. So those are the two numbers we need to grab and return it. We are scanning this array just once while we are storing the value, right? So we don't have to do this nested loop. The time complexity for this is just big O of n, just going through array of list once. The trade-off here is that space. When we did a brute force way, we weren't storing anything, so the space was big O of 1. But because we are storing everything, the space complexity is now big O of n. But is this trade-off worth it? And our answer is of course. The space is cheap, the storage is cheap, but the computation time is oftentimes very expensive. So if you get to use a little bit of extra space using Hashmap to reduce this complexity from n squared to n, especially when we have to deal with a lot of data, this is a very worthwhile trade-off, of course. So let's code it up. Here is the Python solution. It's quite simple. We just want to start with creating a store, a dictionary, or Hashmap that we want to use. Then I'm using enumerate to loop through nums array to access I, index I, and number value conveniently. But you do not need to use enumerate. You can just loop through numbers, and once given an I index, we all know how to access the value. It just really reduced the one extra line of code by using enumerate, that's all. And the first thing that I do is to get a diff, target minus number, so that I can conveniently check if diff is already in the store. If it is, like we discussed, we want to grab the value from the store, which is the index, and a current index for the current value, I, and I'm returning as an array, as a list. If not, I just need to store the number as a key and the value for the index. And when I submit, it is accepted and good enough, and I just move on. And if you are the Java developer wants to see the solution for the Java, here is one. Same method. Instead of dictionary, in this case, I'm using Hashmap called store to store. And only other difference is at the end, I added a return method with an empty list. This is in case when there is no solution in the problem. If no solution is found, and if the question says return an empty list, if there is no answer, then this last line of code will be executed, returning an empty list. But we know that in the problem set there is a one solution guarantee. So this last line of code, the return, will not be executed in this problem. But there are a lot of problems out there says, hey, return this negative value or empty list if the answer is not found. There's a lot of problems like that. So if that's the case, we do need the last return. I thought it was worth adding it so that we can talk about it.